Hi guys, welcome back to our YouTube channel. Today we want to find the value of x given that you have 2 to the power of x equals 5 minus x. So let's see solution. Now from here you have 2 to the power of x equals 5 minus x. Now let's rearrange this. We have it to be 5 minus x to be equals 2 to the power of x. And let's divide through by this. 2 to the power of x, 2 to the power of x. So from here, we have here to be 5 minus x divided by 2 to the power of x equals 1. This divided by this will give us 1. Now, we have to recall that when you have 1 divided by a to the power of m, this equals when you have a to the power of minus m. So now let us now apply this one here. So we are going to have this as 5 minus x, then multiply by 2 to the power of minus x equals 1. Now we want to do something reasonable, or let's multiply through this expression by 2 to the power of 5 and see what will happen. So this implies that we're going to have from here to be 5 minus x, then multiply by 2 to the power of minus x, again multiply by 2 to the power of 5 equals 1 multiplied by 2 to the power of 5. So from here we have 5 minus x, then multiply by 2 to the power of minus x plus 5 equals 1 multiplied by 2 to the power of 5 will be 2 to the power of 5. And how do we get this is that when you have a multiplied by m, a to the power of m multiplied by a to the power of n equals as when you have a to the power of m plus n. So down by applying it here, we have this. Then we have here to be 5 minus x, then 2 to the power of, let's interchange x minus 5 minus x equals 2 to the power of 5. So from here, we have this as this. But let us apply the exponential rule. When you have e to the power of ln of a, this will give us back our a. And the reason is that the exponent and natural log normally cancel each other. So, which implies that we want to apply it here. When you have e to the power of ln of 2 to the power of 5 minus s equals 2 to the power of 5 minus x. So therefore, from here we have 5 minus x, then multiply by e to the power of ln of 2 to the power of 5 minus x to be equals 2 to the power of 5. So, according to law of logarithm, when you have ln of e to the power of m, a to the power of m, this will give us m ln of what? A. So by applying it here, we have here to be 5 minus x, then this one will now be e to the power of this, the whole of this will become here, we have 5 minus x ln 2 equals 2 to the power of 5. So guys, let's check the base, whether the base and the power are the same. The base will have 5 minus x, the power will have 5 minus x multiplied by ln 2. So we want to make the base and the power to be the same thing, because we want to apply something we call Lambert W function. And the Lambert W function says when you have the Lambert W function of a, then multiply by e to the power of a, this will give us back your a. As far as the base and the power are the same, then the output will be either of the one. Now, by applying it here, we can see that our power is different from the base, and the difference is ln2. So we want to make sure that we have ln2 here. The moment when we multiply the base by ln2 throughout the expression, we have here to be 5 minus x, then multiply by ln2, then multiply by e to the power of 5 minus x, then ln2 equals 2 to the power of 5, then multiply by ln2. So from here, we can see we have the base and the power to be the same. So we can now therefore introduce this as W Lambert function of 5 minus x, then ln2 multiplied by e to the power of 5 minus x ln2 equals W Lambert function of 2 to the power of 5, then ln2. So finally, we can have this as, we have then equals W Lambert function of 2 to the power of 5 ln2. Now we are looking at the left hand side, the base and the power are the same. And from W Lambert function of a to the multiplied by e to the power of a always give us back our a. So by applying this theorem here, we have this as 5 minus x ln2 equals W Lambert function of 2 to the power of 5 ln2. Now, we actually want to get the value of x, and we have ln2 at the side. We can divide 2 by this ln2. So this will cancel this. Then we have 5 minus x to be equals W Lambert function of 2 to the power of 5 ln2 divided by ln2. So to get the value of x, we can have this as 5 minus W Lambert function of 2 to the power of 5 ln2 divided by ln2 equals x. And by interchanging, we have our s to be equals 5 minus W Lambert function of 2 to the power of 5 ln2 divided by ln2. So to find the LCM, you can have your s as finally to be ln2, 5 ln2 minus W Lambert function of 2 to the power of 5 ln2. And that is the final answer for the problem. Or you can have s to be equals 5 ln2 minus W Lambert function of 2 to the power of 5 is 32 ln2 divided by ln2. And if you are new here and you find this video interesting, don't forget to share, like, comment, and subscribe to our YouTube channel for more mathematics tutorial videos. And here are the steps. So let me explain how we do it. We have this as this back. We divide through by this as this. Then, in law of indices, when you have 1 divided by a to the power of m equals a to the power of minus m, then we have this. We apply it to this. We have 2 to the power of minus x equals 1. Then we want to manipulate we want to make sure that we have the base and the power to be the same. Then that's why we multiply 2 by this, 2 to the power of 5. So we multiply it, then we get this. Bye bye.